Throughout Earth's history, there have been cataclysmic events that shaped the course of life itself. From the tumultuous depths of the ocean to the scorched plains of the continents, Earth's history is etched with chapters of unimaginable upheaval. These cataclysmic events not only reshaped the physical landscape, but also dictated the very course of biological evolution. These are the 5 biggest mass extinction events that shook the world to its core. Number 5. Ordovician Silurian Extinction. The Ordovician Silurian extinction event occurred approximately 444 to 443 million years ago, marking the boundary between the Ordovician and Silurian periods. The Ordovician Silurian extinction event is one of the most severe extinction events in Earth's history, resulting in the loss of approximately 60% of marine genera. Terrestrial ecosystems were not significantly affected, as life had not yet colonized land to a great extent. The exact causes of the Ordovician Silurian extinction are still debated among scientists, but several factors likely contributed: glaciation, sea level changes, oceanic anoxia, and impact events. During the late Ordovician, there were extensive glaciations, leading to a drop in global sea levels and changes in ocean circulation patterns. These environmental changes may have disrupted marine ecosystems and led to widespread habitat loss. The drop in sea levels during the late Ordovician may have caused significant changes in marine environments, including the loss of shallow water habitats and the extinction of species adapted to those habitats. Changes in ocean circulation patterns and nutrient cycling may have led to widespread oceanic anoxia, particularly in shallow marine environments. This depletion of oxygen would have had detrimental effects on marine life, particularly organisms living near the seafloor. Some scientists have proposed that one or more asteroid impacts may have played a role in the Ordovician Silurian extinction, although direct evidence is limited. Following the Ordovician Silurian extinction, there was a period of recovery and diversification in marine ecosystems during the subsequent Silurian period. However, it took millions of years for biodiversity to fully recover from this event. Number 4. Late Devonian Extinction. The late Devonian extinction occurred approximately 375 to 360 million years ago during the late Devonian period. The late Devonian extinction event led to the loss of approximately 70% of marine species, making it one of the big 5 mass extinctions in Earth's history. Terrestrial ecosystems were less affected compared to marine environments. The exact causes of the late Devonian extinction are still debated among scientists, but several factors likely contributed: climate change, volcanic activity, and oceanic anoxia. During the late Devonian, there were significant fluctuations in global climate, including periods of cooling and glaciation. These climatic changes may have disrupted ecosystems and led to habitat loss for many species. While not as prominent as in some other mass extinction events, increased volcanic activity during the late Devonian could have contributed to environmental changes, including the release of greenhouse gases and aerosols into the atmosphere. Changes in ocean circulation patterns and nutrient cycling may have led to widespread oceanic anoxia, particularly in shallow marine environments. This depletion of oxygen would have had detrimental effects on marine life, particularly organisms living near the seafloor. The late Devonian extinction event had significant effects on marine biodiversity, leading to the collapse of ecosystems and the extinction of numerous species. However, terrestrial ecosystems were less severely affected, and some groups, such as early tetrapods, managed to survive and diversify. Following the late Devonian extinction, there was a period of recovery and diversification in marine ecosystems during the subsequent early Carboniferous period. However, it took millions of years for biodiversity to fully recover from this event. Number 3. Triassic-Jurassic Extinction. The Triassic-Jurassic extinction event occurred approximately 201 million years ago, marking the transition between the Triassic and Jurassic periods. The Triassic-Jurassic extinction event led to the loss of approximately 50% of marine genera and numerous terrestrial species. One of the leading theories for the cause of the Triassic-Jurassic extinction event is massive volcanic activity, particularly the eruption of the Central Atlantic magmatic province. This volcanic activity would have released large amounts of greenhouse gases, such as carbon dioxide and methane, into the atmosphere, leading to global warming and climate change. The release of greenhouse gases from volcanic activity would have caused rapid climate change, including global warming and changes in precipitation patterns. These environmental changes would have disrupted ecosystems and caused widespread habitat loss, particularly in coastal and shallow marine environments. The combination of volcanic activity and climate change may have led to widespread oceanic anoxia, where oxygen levels in the oceans dropped significantly. This would have had devastating effects on marine life, particularly organisms reliant on oxygen for survival. It took millions of years for biodiversity to recover from this event. Number 2, Cretaceous Paleogene extinction. The Cretaceous-Paleogene extinction event, also known as the Cretaceous Tertiary extinction event, occurred approximately 66 million years ago. This extinction event resulted in the demise of approximately 75% of all plant and animal species on Earth, including the famous non-avian dinosaurs. It affected both marine and terrestrial ecosystems. The leading theory for the cause of the Cretaceous-Paleogene extinction event is an asteroid impact. A large asteroid, estimated to be around 10 kilometers in diameter, struck the Earth in what is now the Yucatan Peninsula in Mexico. The impact would have released an immense amount of energy, causing widespread devastation. The asteroid impact would have produced a series of immediate and catastrophic effects, including impact crater, shock waves, global firestorms, as well as darkness and cooling. The impact crater, known as the Chicxulub crater, is over 180 kilometers in diameter and would have been formed instantaneously, leading to massive seismic activity. Shock waves generated by the impact would have triggered earthquakes, tsunamis, and volcanic eruptions, causing further destruction. Debris ejected into the atmosphere would have ignited global firestorms, leading to widespread wildfires and releasing additional smoke and soot into the atmosphere. The massive amount of debris ejected into the atmosphere would have blocked sunlight, leading to a period of darkness and cooling known as impact winter. This would have disrupted photosynthesis and severely impacted global ecosystems. In addition to the immediate effects, the Cretaceous-Paleogene extinction event led to long-term environmental changes, including climate change, ocean acidification, and the collapse of food chains. The release of greenhouse gases and aerosols into the atmosphere would have caused short-term global warming, followed by a period of cooling due to the blocking of sunlight by debris. The impact of the asteroid and subsequent environmental changes would have led to ocean acidification, which can have detrimental effects on marine organisms. The extinction of dominant species such as the dinosaurs led to the collapse of food chains and allowed for the rapid diversification of surviving species, including mammals. The Cretaceous-Paleogene extinction event represents a significant turning point in Earth's history, marking the end of the Mesozoic era and the dawn of the Cenozoic era. It paved the way for the rise of mammals and ultimately led to the development of modern ecosystems. Number 1. Permian-Triassic extinction event. The Permian-Triassic extinction event, often referred to as the Great Dying, is the most severe mass extinction event known in Earth's history. It occurred approximately 252 million years ago, marking the boundary between the Permian and Triassic periods. The Permian-Triassic extinction event led to the loss of approximately 96% of marine species and 70% of terrestrial vertebrate species. It affected both land and sea, leading to a significant restructuring of ecosystems. Pinpointing the exact causes of the Permian-Triassic extinction event is difficult, mostly because it occurred over 250 million years ago. And since then, much of the evidence that would have pointed to the cause has been destroyed or is concealed deep within the Earth under many layers of rock. The seafloor is completely recycled each 200 million years or so, by the ongoing processes of plate tectonics and seafloor spreading, leaving no useful indications beneath the ocean. Yet scientists have gathered significant evidence for causes, and several mechanisms have been proposed. The proposals include both catastrophic and gradual processes. The catastrophic group includes one or more large bolide impact events, increased volcanism, and sudden release of methane from the seafloor, either due to dissociation of methane hydrate deposits or metabolism of organic carbon deposits by methanogenic microbes. The gradual group includes sea level change, increasing hypoxia, and increasing aridity. The Permian-Triassic extinction event had profound and long-lasting effects on the Earth's biosphere, leading to the collapse of ecosystems and paving the way for the rise of new species during the Triassic period. It took millions of years for biodiversity to recover from this catastrophic event. Overall, the Permian-Triassic extinction event serves as a stark reminder of the fragility of life on Earth and the potential consequences of environmental perturbations on a global scale. As we conclude our journey through the annals of time, remember this: the story of Earth's greatest mass extinctions is not merely a tale of loss, but also one of resilience, adaptation, and the unyielding spirit of life itself. But even today, life is full of wonders. There are countless of animals thought to be extinct for hundreds or even millions of years, only to be seen again in modern times miraculously. So make sure to watch my other video right here, where we talk about the incredible comeback stories of 20 animals thought to be extinct. Thank you for watching, and I will see you guys there.